So can you guys hear me okay? All right, okay. So I'm Scott Kaler. I work with Adknowledge. A little bit of background on me is I started in the technology industry in, it would have been the mid-90s. Is anybody here from multi-service? Awesome. I would like to thank you guys because back in the mid-90s, I was on Metropolis BBS stuff, and that is what got me into technology. Scripting for my character to move around and stuff like that in some buds. That's where I started my technology career. From there, I decided, it can actually be a job, which was amazing to me because back in the 90s, I didn't think anybody did technology as a job. People make games and stuff. So I decided to go looking for a job in technology. I ended up at a company called Nets Inc. in Lincoln, Nebraska. They do point of sale and ATM traffic, monitoring ATMs running, that kind of thing. That's kind of where I got my introduction to big data. Well, what I thought was big data at that point in time. Nets Inc. had a massive closet that had reel tapes in it. And they were numbered from 1 to 1,000. So you'd walk into the closet and, it's all these reel tapes from the tandem computers and dang, look at all this data. It was amazing. So as part of this, I was trying to do some calculations, and I think I calculated that each tape could hold about 140 meg of data at its best. So if I do that calculation and I think about it, well, that is 140 gig, I believe, that could be held on all those tapes. So if I was looking around my house, and we've got, there's micro SD card, 32 gig. So if I have 5 of these, I can hold what was in this closet of tapes, okay? That's how much the technology has changed in, what is it, close to 20 years, So that's the other thing to keep in mind is what we think of as big data now, 10 years, 20 years from now, could be totally different. And it will be totally different. So, going from there, let's see here, what's my next slide? Talking about Adknowledge. Some of the things you should know about Adknowledge is that we process, in our system, we have hundreds of millions of users that we try to target. And the targeting that we do is a little bit different than your standard advertising targeting. Your standard advertising targeting is based off of, I'm on a pet blog, they have an ad space, so therefore the ad that pops up needs to be about pets. That makes some sense. A lot of what Adknowledge does, where possible, is behavioral targeting. And I've got some very intelligent guys from my company right here that make all this run. The behavioral targeting is looking at somebody's past history, trying to figure out what it is they like, what they do, and generating a recommendation about what we think will interest them and get them to click. This behavioral targeting is a much more complex algorithm to try to figure out what's going on. We generate billions and billions of these recommendations every day. We generate these for hundreds upon hundreds of millions of users. So if you look at, I think they believe there's going to be 2.2 billion internet users in 2013. If you were to take the number of recommendations that we create, I believe we would be creating at least 2 recommendations for each person. Now, we don't have that many people in our system, right? But assuming we had everybody in the world in our system, that's how many recommendations we're generating. Let's see here. Oh, cool fact. Adknowledge was started in 2004 by a guy named Scott Lynn. When he started the company, he was 24 years old. So he's doing fairly well to have brought all this along, starting from the age of 24. I wish I would have done that when I was 24, but, it didn't happen. So why are we here talking about big data? assume you guys all have questions, so I'm going to try to answer some of that. One of the things is big data is in the news. I'm going to guess a percentage of you. How many of you guys have heard of Hadoop? That is much better than when I went to EMC World and they asked that question. So that's very cool. How many people have heard of MongoDB? Wow, that's cool too. How about Couchbase? Still doing pretty good. Okay, all these are traditional things that you would see associated with big data. So in the news, you see plenty of things talking about how Facebook is using big data. In the technology news, you see plenty of things talking about how Facebook's using big data, how Yahoo's using big data, how Microsoft is using big data. And it's kind of becoming one of those new buzzwords like cloud or virtualization, and it's there. And, you know, really that doesn't surprise me. It's a cool technology. It's out there. You're starting to see big data, well, not necessarily just starting, but big data is popping up in financial stuff too. eBay is saving millions of dollars using big data. This actually talks about eBay is using their backend to monitor their servers, collect all the server data, and they're finding cost savings there. But it's becoming financially viable. It's not some project that people are losing tons of money on. There are real returns on using big data to do things. So what's even more amazing than that is it's in the mainstream news. You have Mitt Romney is using data mining to find campaign contributors. Now, depending upon which side of the fence you're sitting on, people will say, ooh, that's evil, evil Republicans scouring data. Or they'll say, hey, he's a really smart guy going out there and doing this, looking for data. So I saw this article, I thought, oh, that's kind of neat. There's two sides to that. I see how people could take it differently. So I went looking, and this is from 2 months earlier. You have President Obama is out scouring big data for contributors and stuff. So either he's the evil Democrat or he's very intelligent. It just depends on which side of the fence you sit on, right? So it's in the mainstream news. People are using it. Big data is out there. So one of the things about big data is where's all this big data coming from? We're capturing all this data. What's going on? So in this article, it's kind of tough for me to read here, so I really doubt you can read it out there. It says there are already about 35 billion devices connected to the internet, and there are well over 1 trillion devices with network potential. Okay? A lot of times you'll see people talk about sensors, and a lot of these network devices that you have are what they consider sensors. They're sending information back to some single source that's ideally capturing it. Your phone is a great sensor, right? It's got your GPS data, it's got your information, you're connected to the internet. I kind of hope when I shake it around like this, it's really making some guy at Google mad because the data doesn't make sense. The GPS is going all over, or the accelerometer is going all over the place, right? There's all this data coming in from all these sensors. That's the other big piece of big data is now we're collecting all this data that's out there and it's all coming in. So as you can see here, our collection of big data is just skyrocketing. And this looks at 2012 and it's starting to go up. The other fantastic technology is that the cost per gigabyte to store data is going dramatically down. If you looked at, I'm trying to think, it was maybe 3 years ago, I was looking at buying a laptop, right? And I wanted to get it with an SSD drive. I would have to sell one of my children to get a 32 gig SSD drive to put into my laptop. These days, you can get a SSD drive for your laptop for under $1 per gig. So I believe I saw it was a 256 gig SSD drive for 200 bucks. The price is dropping out. Another part of this is storage, especially when we talk about this big data stuff. The cost to store data, they're dramatically reducing the platform cost to store big data. This is another reason I think a lot of people are here, is you have the market forecast for big data here, $5.1 billion. That's pretty good. 5 years from now, $53 billion. It's skyrocketing. Now this number is based off of manufacturers, analytics providers, people that provide the stack the big data runs on. It's a whole bunch of different companies, but you can see the amount that is going to go into big data is skyrocketing. So there's potential. This is one of my favorite graphs. This is the Gartner's, I believe they call it Gartner's height potential for technologies. So I really like, you see big data is up there, and it's in this section right here, which is called the peak of inflated expectations. So what that means is everybody thinks right now, I'm going to stand up a Hadoop cluster, and it's going to solve all my problems. And it's that magical, all right? And people will say, I think I need some of those Hadoops because we're not trending very well. That's not quite how it works. There'll be a point here, which they call the trough of disillusionment, where people will figure this out. Well, I dropped in a Hadoop stack, and I didn't make $1 billion. What's wrong? Then there will be a point after that where people start to figure things out, and it becomes very productive. The good news here is you see big data has a little light blue dot there. We're talking 2 to 5 years. We go from here to over here. That's fast. Big data is moving fast through this. This is also one of those things where I feel, if you feel that this is too scary for you and you sit out, it's kind of like where they talk about playing your 401k and moving your money around all over the place. You start moving your money around, the problem is you shift it to something, you might miss out and end up trying to get it back here at this point. You missed the upslope. So I guess I would make the argument that while it's inflated expectations, right now is a good time to get into it and look at it. So what is big data? This is what most people think big data is. This is the symbol for Hadoop. Hadoop and big data seem to be synonymous. Talk to most people, and they'll say, oh yeah, I know about big data. We run a Hadoop cluster for big data. Big data is not Hadoop. There's a lot more to the stack than just Hadoop. Hadoop's a very big part of the big data stack, but it's not all there is. These are things that are labeled big data technology that somebody has talked to me about recently, or I've looked at, or considered recently. So, I mean, we have all sorts of things over here. MongoDB, this is GlusterFS, Percona, version of MySQL, Isilon storage systems, React, Microsoft SQL Server. All these things have labeled themselves, or somebody has labeled them big data. And I think they're pretty accurate, because there's cases that could be made that each of these are big data. I wasn't sure what the heck that one was at first when I went and looked. That's Memcache. Memcache has been around for a while. I feel Memcache falls into the big data market because people are putting terabytes and terabytes of data in Memcache spread across clusters. That's big data. If you go out to Forbes and look at their big data landscape, say, you thought my picture was scary? This is Forbes' picture of big data. They have so many names in here that I can't even begin to tell you what all the stuff is. Where I personally deal a lot is in this section here, some in the structured databases, and some up in this section here, a little bit here. I'm kind of at the low level of my company as far as I build the platforms that all the big data stuff runs on. There's a whole huge amount of business intelligence, visualization. I think John, who's sitting here, probably gets calls once a week on one of those things. So now we really get to what is big data. So the masters of information, Gartner, they classify big data as high volume, high velocity, and or high variety information assets that require new forms of processing to enable enhanced decision making, insight, discovery, and process optimization. Okay, so what I can say from that is I can skip over the first half of it, and if I go to enable enhanced decision making, insight, discovery, and process optimization, I could probably tack on service-oriented architecture to the front of that, and they would apply it. You might be able to tack on virtualization to the front of that, and they could possibly try to apply it there. So I think the key things are high volume, high velocity, high variety information assets. They call those the 3 big V's of big data. So you got the 3 big V's of big data. You have volume. It's big enough traditional storage methods need reconsideration. So you can buy a server the size X. Well, I've got more data. Well, we're going to add more disks. Well, I've got more data. We're going to add more disks, and we're going to attach a storage unit. We'll throw a SAN on there. Pretty soon you start to run out of the amount of space that you have. This is where, in the big data system, a lot of things are node-based, and you can just build out by adding more nodes to it. It's the great thing about Hadoop, Greenplum, Memcache, React, any of that stuff that's out there. You need more space. Ideally, you just add another node, your namespace grows, and everybody's happy. The additional thing that goes with that is when you go to replace hardware, the ones that are good allow you to say, well, this server's 3 years old. I'm putting in another server. It expands the space. I take this old server out, and we're okay. You stop running into things like, I have a platform that is my SAN. I need to make it bigger and make it do better. I have to do a full-scale swap out in order to do that. I will say the SAN manufacturers are getting much better about that kind of thing, but that's something that I personally run into in the past. So volume is a good indicator that you're working with big data. Velocity is the other thing they talk a lot about. Velocity is churn, input, and or output surpasses normal data loading mechanisms. So you've got your MySQL job, and you do a MySQL load, toss it in there. Well, it's taking 2 hours. It's taking 4 hours. It's taking 8 hours. We're not getting it done in a day. What do? Big data is addressing this in a variety of mechanisms. Usually it's parallel loading, loading into memory. There's a variety of ways that they address this. If you're looking at data that you're working with and you realize your traditional loading method is not working, you're probably going to be looking at big data. Variety. This is a fun one. Some people say yes variety. Some people say no variety. You can have big data without having variety. You can have structured data and be in big data. My opinion. I mean, there's lots of opinions out there. There's database. You grow your database server out, structured data. You can have big data. The reason this comes up a lot is because many of the platforms out there, and much of what you will run into now, you'll be getting data that is not structured. You'll be pulling from somebody JSON objects down. You've got your Apache logs. There's a variety of things you're going to be pulling in that you need to process as data that doesn't fit pretty columns that you have in your database. So variety of data sources is another big piece. So this is what I say. Big data is scale-out architecture applied to data processing and storage. So we had, what would that have been, mid-90s, early 90s possibly? No, mid-90s, late 90s. I think of things like LiveJournal, where they started scale out. You're talking about scale out infrastructure, right? Problem is now you have data that comes from this web infrastructure that you scaled out. So you need to start looking at scale out storage. This is what people are getting effective at doing, is they're getting effective at taking commodity hardware and scaling your storage out to be able to use, make use of the scaled out infrastructure you had on top of that. It's a very good indication that you're working with big data. If you're looking at a solution and they say you don't need to buy bigger boxes, you just need to buy more of them. This could be off-the-shelf hardware. This could be their special appliance. Most people will sell you that it's if you're buying an appliance, it's not really big data, but I've looked at the Isilon product, and I would say that the Isilon product is big data. Okay, so what's the big deal with big data? What's cool about it? So, have people seen a graph like this before? You guys know what an RD is? Who knows what an RRD is? Okay, RRD, round robin database. Great thing for networking guys. Been around for, God, as long as I know. So the idea of RRD file is you say, I want to collect 1 minute statistics. Well, actually, you say I want to store 1 minute statistic, 5 minute statistics, 24 hours, 1 week, and a year, let's say, for instance. I want 300 of each of those. So what happens is you throw your data into the RRD file. It says, okay, well, I've surpassed the number of 1 minute statistics I can hold. I'm going to roll that up, and those will go into 5 minutes, the months, and the years. It works pretty good. The great thing about this is you create a data file. It's of a set size, and the statistics go into it. And essentially does roll-ups for you, which is what everybody's been working off of, right? So in this instance, I'm looking at traffic one of our servers is doing. So I go out, and the process here is I need to buy a switch for a rack. I've got 42 servers in my rack. We're going to say it's a really tall rack, so it's got some extra space at the top. I need to decide whether I want to buy a blocking switch or a non-blocking switch. Non-blocking switch says for every port that's on the switch, there's enough backplane that all the data can go through. Blocking switch says that I don't have the bandwidth to cover every port. So you got a choice of I've got a switch, I can save money and get a switch that does 16 gigabyte of throughput, or I can spend more money and get a switch that does 48 gig of throughput. So as a person who's deciding to buy the switch, I look at this graph and I say, wow, well, let's see here. We're at about 100 meg. Well, I can go with the low-end switch because 42 ports times 100 meg is 4.2 gig. I'm going to be way underneath that 16 gig. It's no problem. And I start looking at the data. I zoom in a little bit. And I look at the last week. Because the problem is the RRD file, he's only the latest 300 of each of those segments, right? So now at the year, you're basing stuff on daily averages. Well, so I zoom into a week, and well, my 100 meg isn't there anymore, and I'm seeing spikes at 300 meg. Well, that's not too cool. That means 42 times 300 meg is 12.6, which is getting me kind of close to that 16 gig that I need to buy the more expensive switch at. But my other graph didn't show me that. So hey, I'm going to look at my graph that shows minute by minute. Uh-oh. And that's the problem. I'm showing we're doing some 400 meg spikes. And actually the server does more than 400 meg spikes. Depends on where you catch it at. That's 16.4 gig. Well, that's a real problem because if I would have bought the switch that I saw from my original graph, looking at the whole year, I'd end up not having enough bandwidth to handle my spikes. My servers wouldn't be able to talk to each other. I'd be dropping packets. Well, that's not good. So what big data is allowing us to do is instead of doing these roll-ups like you see in that instance, big data takes source data and saves it. And the idea of big data is that you save the source data, or one of the major uses of big data is you take the source data and you save it and you churn your insights from that source data. So you can drive your insight from a year ago on Tuesday, my source data says I did this much traffic, rather than having a roll-up that says, well, during the whole day on average, we did X traffic. And this comes back to if you wanted a literary analysis done on something, do you go to the person that has the book, or do you go to the person that has the cliff notes? I want to know about Les Miserables. Well, I might read the cliff notes to get a brief overview, but if I want somebody that's a pro to interpret it for me, I want the person that's read the whole book so they can tell me the ins and outs and analyze it and do everything. And that's what one of the biggest use cases for big data is. And when you start looking at big data, there's Hadoop is great for this, LexisNexis, Greenplum, all these things are about storing large amounts of data and churning information from that source data as opposed to relying on roll-ups to present you with an abbreviated amount of data. And ideally, you're talking to your finance person, and your finance person knows what the transactions are that are going on. Not that in 2012 you had an income of $65,000 and that's all I know about you. So I can't really tell you whether you can go on vacation or not. I know you made this amount of money. Ideally, they have each little piece and they can give you good information. Your predictions, anything you come up with is going to be better coming from source. Another big use for big data is when they talk about if you were to do split testing or A/B testing. Let's say I have a website and we want to figure out which color is the best for the website. The marketing people say this year is really hot. Pink neon is the new color. That's what we need to go with. We're going to test that on the website. But then you've got your developers say that no, the dark blue that we've used for the past 5 years has been great and it works good. So you decide to do an A/B test. Okay, well, for some people they'll get the neon pink and some people they'll get the blue. And then we're going to put that into our website. We write that code. We have an identifier. Google Analytics picks it up and ideally lets us know what's going on, and we get that data back in 3 hours, maybe less if we're a pretty good-sized website, maybe longer if we're pretty small. So the problem that happens during that is you have to wait a certain amount of time. Let's say nobody likes the hot pink, neon pink website, so you tank, your sales tank on that site. Ideally, you want to know that right away so you can shift off of that and say, no, that didn't work out. That's where big data is doing ingestion pipelines. As the data comes in, you have a stream that goes through and it forks off the data to tell you immediately whether something's working or not. Whether your end repository is a database, memory cache, storage, you have a pipeline that the data goes along, and you can say, at this point, the data needs to go here and update it. This is how Twitter works. It keeps updating real time, right? If it all had to go back to one big source and get rolled up constantly, you'd be looking at hours and hours for it to process. So event ingestion pipelines, turning hourly, if not daily event reporting into real-time data streams. Things you'll see talked about that are Storm, S4, which is Yahoo's S4, not Amazon's S3, different things. Flume is another one they're using for event ingestion. And events could be log data, it could be a sale. There's a whole bunch of different ways to declare what an event is. Big data is also being used for mashups. Poster boy here, we have Facebook. So we have my feed of my friends. I've got my groups are doing stuff. I've got my other friends up here, my applications. These are all from disparate data sources, bringing all that data together. Massive in-memory data stores and distributed databases are allowing for immediate update and joining of large data sets. So we're moving this data into memory so we can drive insight from it quickly and update our web pages or whatever they may be in a timely manner. You don't want to get on Facebook and see what happened 5 hours ago. You want to get on there and see what happened 3 seconds ago. Couchbase, MongoDB, HBase, these are things that are allowing you to move that storage and those actions up into memory. This is Michael Phelps. I hope you guys, everybody knows who Michael Phelps is. There was the Olympics in 2008. Everybody had the full bodysuits on, right? And everybody's swimming really fast, and they're saying, wow, this great technology, it's making everybody swim really, really fast. You know what we're going to need to do, though, is we've decided this technology is too powerful. We're going to ban it, and then we're going to put little asterisks by the record names because the technology was too good. Well, we come back to this year. People are swimming just as fast without the technology, and they're breaking records. Well, how does that happen? It's because it's the people, it's not the technology. As part of the hype cycle is that you can't throw a Hadoop cluster in there and it magically solves your problems. You need to have people that can work with that and drive those insights. You can get the greatest tools you want, but if you don't have the people to work those tools, they don't do you any good. So where does this leave us with big data? One of the things I wanted to address is where I think big data will make the most impact. Virtualization. I would say the biggest impact for virtualization was in the large enterprise. You've got a sprawling data center full of servers. You're able to virtualize things, take older ones down, not necessarily have to rebuild that server. You can virtualize it into a virtualization unit and run with that. This was great for getting rid of some 3U servers we bought in 2001 at one point. Virtualize it. Server can still run, just somewhere else. Biggest impact was the enterprise, from my perspective. Cloud computing, another big buzzword technology. Cloud computing, biggest impact, I would say, is small businesses. So now, somebody who has no access to a huge infrastructure can hop onto Amazon, rent 100 servers for an hour, run a big data set through it, just like the big guys do. I mean, it's possible now. You can do that. You can be a guy sitting in your basement and run on an infrastructure as big as we have, you know, without all that investment. It has really empowered the small business user. So where does big data fall in this? I think big data is going to be more at the enterprise as far as enterprise generating big data sets. There are big data sets out there for the medium and small business. But I think as far as people building their own clusters to do things, the biggest impact is going to be at the enterprise level. With that said, big data is going to affect everybody. Because with the enterprise using big data, you have things like your power companies. They can look at what your usage factor is for your house for every hour of the day, ideally with big data. So that information is going to roll down and affect your bill in the end. The targeting that you see on your telephone when you get a map out and they say, oh, well, you know, we just looked and saw you took the same route yesterday, but traffic's a little bit rougher. You might want to go around this other way. That's big data affecting everybody in a very personal way. So while enterprise, I think, will be the most using big data, we will all be affected by it. So we get back to the who should be looking at big data. Inflated expectations right now. I think the best idea for people is to look at big data right now and figure out if it works for them. If you wait years to look at what big data is doing and figure out how it fits into your scheme, you're going to be behind the curve. When you go to implement it years from now, you will have failures. Things will not go right. And you'll have to go back and figure out, again, what's the right answer for this. Right now, it's at a smaller scale. It's growing. People are figuring it out. I would say hop in now. That way you can benefit from everything growing and understanding. People are also very open to sharing right now. You can jump on message boards and people will talk about what they're doing with big data. The great thing is we're having an event here in Kansas City and we're talking about big data. I mean, it's hot. It's in the news right now. You can walk and talk to people about what they're doing with big data. Now's the time to get in and to understand what's going on. Get your business ahead for what's coming in the future. If I was to tell you one technology, you were to come up to me and say, hey Scott, I'm thinking about doing big data. What do you think I should do? I would say what you probably want to look at is Hadoop cluster. You can run Hadoop cluster on one node, see how it works. You start getting into the 3 or 4 node, probably for a production type environment at a very small scale. I think Ryan is going to cover that kind of thing later on, so I'm not going to discuss too much about servers you would use. But the places I would look would be Cloudera, MapR, and Hortonworks. They're the 3 big providers of vendor-based Hadoop stacks. They have a support layer that they offer on top of Hadoop. They each have their own little ins and outs. I would say Cloudera is more enterprisey, MapR is faster, and Hortonworks is going to be more cutting edge. Hortonworks came out of Yahoo. They were the guys that were doing a lot of the Hadoop implementation early on. So you will see them probably keep up closer to what the current Apache Hadoop version is. These are our marketing slides. This This is where we talk about, well, Adknowledge, just so you know, has offices all around the country. I'm trying to think of some of the cool stuff. If you guys ask later in the panel, we're going to have our some of our doctors that are the data analytics team up here. Our data analytics team is the people that does a lot of the thinking around our big data. I do the platform implementation. They do the, here's the data, how are we going to use it, how are we going to make it work. Working with the DA team, your first day meeting the DA team is a lot like Spies Like Us. There's a scene where they go out and they walk into the doctor's tent and everybody walks around, doctor, 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 doctor. That's our data analytics team. It's like everybody's got a PhD. It's pretty crazy. So, you know, this is how they think, I guess. So, I don't know. They're a very smart group. We're all over the place. Oh, I'll just say that Adknowledge is hiring. We need people. So, you know, some of what I've talked about, big data, is throughout our company. We're using Mongo, Redis, large instances of MySQL, Greenplum, Hadoop. The way Adknowledge works is we have tons and tons of different technology, and developers are trying different things out all the time. That's part of what makes Adknowledge work. Is there is no one right solution. You need to be constantly evaluating what the right solution could potentially be because there's new technologies coming out all the time. Technology moves forward. If you maintain, you're falling behind. And that's one of the things Adknowledge excels at, is trying different things. So with that, I will end my presentation. I guess, you want to move on to the panel? Okay. We're going to move on to the panel then.